Hi and welcome to NM1200. Today I want to talk to you about white balance, but in doing so we're going to have a chat about color temperature as well. So these terminologies may not be familiar to you, but as we unpack them, I hope that you can gain some understanding. So when we think about light sources or light, each has a very particular color temperature associated with that light. So if we think about what light sources are available, there's daylight, which can be direct sunlight. It can be in the shade, so open shade, or another type of daylight might be cloudy, so when light is diffused through cloud cover. When we think about artificial light sources, you have tungsten, which is the old-fashioned bulbs, fluorescent lighting, flash and discharge lamps. But we also have now LED lighting as well, so we should add that onto the list. All light is made up of red, green and blue light waves, which create white light, correct? However, it's the way or the mixture or the dominance of any one of these light waves or the absence of any of these from your colour, your spectrum, which will create a different light except for white, pure white. Okay, so let's continue this conversation. Color temperature refers to the color bias of light sources. When you think about those light sources that I just said to you about daylight, the different types of daylight, plus artificial light sources, each of them have a defined color temperature. So color temperature is expressed in units of Kelvin, and they're measured in comparison to the color of a blackbody radiator when heated. So 1 unit of Kelvin equals 1 unit of Celsius. However, when you've got 0 Kelvin, it's minus 273.15 degrees Celsius. You might never need to know that as a photographer, but it's an interesting little tip. So, color temperature is measured in kelvins against the heated black body. And when we think about light sources such as candles and sodium vapor lamps, they've actually got quite a low Kelvin reading, okay, and they're a really warm color temperature. So if you think about the color temperature or the color that's emitted by a candle, and sodium vapor lamps are your big street lights, what color are they? Those big warm or colored street lamps. Tungsten or photo flood lamps are still in that warm area of color temperature, so they've gone up to between 3 and 4,000 Kelvin. So when you associate the color temperature of these type of tungsten lighting, so tungsten lighting is that old-fashioned light bulb, remember, then it's between 3 and 4,000 Kelvin. So noon sunlight sits between 5 and 6,000 Kelvin, but in fact it's quite a neutral light. There's no or very little color temperature or color bias associated with sunlight in the middle of day. So if you're looking for that neutral light, then that's where you'll find it. This changes quite dramatically when you have light filtered through cloud cover. So on an overcast day or a cloudy day, all of a sudden the color temperature or the associated color bias of that light sits between 6 and 7,000 Kelvin, close to 7,000. Clear blue sky in the shade. So remember this, clear blue sky, but in the shade is very cool. So we call cold light or cool light. So it has a very blue color bias or associated color temperature. So there's a lovely chart which will actually represent, so visually you can see how light ranges from the reds down here to 1000 Kelvin. There's your candle flame, sorry, your sunrise and sunset, there it is, 2500 Kelvin. A light bulb, that tungsten light bulb, 3000. Morning, evening sun, about 3.5, and moonlight around your 4000. Midday sun, see, sits in this lovely neutral area here, and then we get into the cool tones again. Cloudy sky, so overcast days, and your clear blue sky, which is actually that colour clear blue sky, but in the shade it's when you find that really, really cool colour temperature, or that blueness, sorry. So, how do we deal with this light? Now we know that light isn't white. We look at it and we see white, but as you train your eye, you can actually see these differences in colour. So in the camera there is settings for white balance. So that's balancing that light, or that ambient light, on that associated colour balance back to neutral. So especially when you're shooting with JPEG files, it's really important that you set your white balance. Now, when you're photographing using and capturing raw data, you can actually set your white balance in the processing stage, but when you're shooting with JPEGs, it's impossible, absolutely impossible, to correct an incorrect white balance setting on a JPEG file. You just got to go and shoot it again. So in your camera, this is the settings that you'll have available, okay? And if you look in your manual, this is exactly what you'll see. So automatic white balance, AWB, will set the camera sets a white balance automatically. So it actually sets it to around 3 to 7000 Kelvin. Now this does a fair job most of the time. When you have quite mixed light sources or mixed lighting, that's when this won't quite work properly. But for the majority of the time, if you set the camera on automatic white balance, it's going to do a great job. However, the best way to do is for you to work with white balance is to identify the type of light, understand the color temperature of that light and the associated color bias, and then select the white balance setting appropriate for that light. So for sunny, daylight and outdoors, so no bright sunlight, you're going to set your camera on daylight white balance. If you're working in shaded areas, you're going to be choosing this setting. For cloudy or hazy days and even during sunsets, you can use this little setting here with the little cloud icon. When you're working with tungsten lighting, now tungsten lighting is actually less common now than what it was when all this was formulated, but if you're working with tungsten lighting, then you use the little light bulb. Fluorescent light is different to tungsten light though. So fluorescent lighting has an absence of magenta, so which means that if you don't set your camera appropriately, all your images will have this odd green bias to them. So if you're working inside under fluorescent lighting for any reason, ensure that you do set that fluorescent, or choose that fluorescent light setting. When you're using flash, there's a setting for that as well. Now LED lighting is fairly neutral, but be careful because if you go now into the shop to buy yourself a light bulb for in your house, say, look at the options that you have. You have warm, cool or daylight bulbs, okay? So think about the appropriateness or how you would actually set your camera up with any of those. So if you like or you prefer that that cool bulb, and you get them in the fluorescent lights now, or those energy saver lights as well as LED lights. If you've got that, then make sure that you're setting your camera for hazy days. If it's warm, make sure you're setting it for tungsten. If it's daylight, then you're working with sunny daylight outdoors. So no, as you become, I suppose, as you photograph regularly and you become more sensitive to color bias in light, you'll find that no, you'll pick a light source as you walk in because it will be instantly evident. You can do a custom white setting as well, okay? Or you can also manually set the color temperature in the camera in the settings. Okay, so there's your settings again. So remember, auto does an okay job most of the time. Otherwise, choose a specific setting for the type of light that you're working in. So, what happens? Let's have a look at some examples. So these are examples set. So this is the light source is tungsten lighting. So it's that warm light, remember. And this is how the images appear, or how, no, the final image appears with tungsten lights source and an automatic white balance. You see it's an okay representation of the colours in the image. What does it look like with the daylight white balance setting, shade, cloudy? Oh, and look what happens here when we have the right white balance setting for the light source. So in fact the background isn't warm, it's not these these ochre sort of brown colours, it's a grey background. And can you see now how these reds are a pure clean red and the whites are pure white? Okay, so the colours have changed considerably. Now when you're working with colour critical work, this is so important for you to understand. So light source is tungsten, white balance setting is tungsten. Cloudy lighting. So at the moment, this is shot. Here's your light source is cloudy, so it's overcast light. This is the result with auto white balance. Look, it's a reasonable result. Look what happens when we put the wrong white balance setting in though. So the image becomes even cooler than what the light, the color bias is in that light source. Shade, aha. So this is getting better, isn't it? So on a cloudy day, shooting with the shade setting, everything becomes quite neutral. But on a cloudy day, with the cloudy setting set, this is actually the correct color. This one's too warm, this one's just right. And you see there's very little difference, or I can see that there's difference, but there's very little difference actually between auto white balance and cloudy, except for this one is more warm. Can you see there's just a more warm or more yellow in that overall colour here? So there we are. Cloudy lighting, so the light source is cloudy, and tungsten setting and flash. So remember that it's important to set that white balance correctly. You can do this exercise yourself. There's actually a tutorial task sheet for you to follow to experiment or to log your own testing of light sources and white balance settings. So some questions that are always asked, is setting that white balance on the camera critical when shooting JPEG format? Absolutely. Because JPEG is a lossy format, it's already compressed. So when you photograph using with the camera set on JPEG, the camera actually processes the image and compresses it, and you get a final image. Okay? So you can't do any changes after that, and it's really, like I said, it's impossible to actually fix up a JPEG file that's been photographed with the incorrect white balance setting. However, now as I said at the introduction, when you're shooting in RAW format or you're collecting that raw data, you can actually then set your white balance. It's one of the first steps when you're processing those raw images. So we just went over this. So white balance can't be really corrected properly um, with if with an incorrect JPEG capture. Look, you might do some minor adjustments, you might do some minor fix-ups. It's only a minor error, but in reality, no. Shoot properly in the first place instead of trying to fix badly shot images in post-production. Look, post-production should be considered an extension of your image, not a way of fixing up a badly shot image. And white balance absolutely can correct it in post with raw format images, and yes, that's a preferred method. So you don't even have to really be concerned about photographing or setting white balance when you're shooting raw, because no, that raw format contains all the capture information, and you as the photographer makes informed choices about how you want to process it, including the white